Hi guys, welcome to my channel. I Rakshita currently pursuing BE in Sri Venkateshwara College of Engineering. Since this is my first video, let's go through rectifiers. Introduction. What are rectifiers? A rectifier is an electronic device which converts an alternating current into a direct current by using one or more PN junction diodes. A diode behaves as a one-way value that allows current to flow in a single direction. It's called rectifiers, which converts which converts an AC into a DC by using a PN junction diodes. It mainly consists of two types, full wave rectifier and half wave rectifier. Let's go through full wave rectifiers. What are full wave rectifiers? Which converts an AC voltage into a DC voltage using both half cycle of an applied AC voltage. It uses two diodes of which one conducts during one half of the cycle while another which conducts during another half of the cycle of an applied AC voltage, and which consists of an two diodes and the current flows through opposite direction, and this current flows in a negative half of the cycle. And this is an transistors, and this is a circuit diagram of a full wave rectifiers. Output of a full wave rectifier. The average DC output voltage is higher than the half wave rectifier. The output of a full wave rectifier has much less rapidly than that of a half wave rectifier, producing a smoother output waveform. You can see in this, you can see how the output is being. These full wave rectifiers are classified into two types: center tap full wave rectifiers, full wave bridge rectifiers. Now let's go through center tap full wave rectifiers. A center tap full wave rectifier is a type of rectifiers which uses a center tap transformer. This is a transformer and two diodes to convert and complete AC signal into a DC signal. A center tap full A center tap full wave rectifier is made up of an AC source, and the center tap transformation consists of two diodes, that D1 and D2, and the load line, and also the load line. Working procedure of a center tap full wave rectifier. During the positive half of the cycle, the diode D1 is a forward bias as it is connected to the top of the secondary window, while D2 is a reverse bias which is connected in the bottom window. Due to this, diode D1 acts as a short circuit and D2 will not conduct action as it is because it's an open circuit. During the negative half of the cycle, the diode D1 will be the reverse bias and diode D2 will be a forward bias because the top half of the secondary circuit becomes negative and the top bottom of the circuit becomes positive. Thus, in this full wave rectifiers, DC voltage obtains both half cycle, and full positive half cycle and also negative half cycle. Now let's go through bridge rectifiers. What are bridge rectifiers? Bridge rectifiers it consists of four diodes are arranged in the diode, which consists of four diodes, as you can see in this. As you can see in this, like D1, D2, D3, D4 consists of four diodes. This configuration provides same polarity output with either polarity. The main advantages of this bridge rectifier is that it does not require a specific certain tap transformation. A single A single secondary window is connected to the one side and the diode bridge networks and the load out of other side. Load to other side. Let's go through working procedure of full wave bridge rectifiers. When AC signal is applied across the bridge rectifier, the terminal A, we can see in this, the terminal A becomes positive during the during the positive half cycle, while uh, while uh, while trans while terminal B becomes negative. This results that D1 and D3 diode D1 diode D1 and D3 becomes forward bias, while D2 and D4 will become a reverse bias. During the negative half of the cycle, the terminal B becomes positive while terminal A becomes negative. In this causes that diode D2 and D4 becomes a forward bias, and diode D1 and D3 becomes a reverse bias. Current flow across the load line RL, current flow uh, the current flow across the load line RL is the same during the positive and negative half cycle. The output DC signal polarity may be either completely positive or negative. In other case, it's completely positive. Let's go through the theory of a full wave rectifiers. In full wave rectifiers, we can use two diodes as I said before, and one of each half of the wave. The multi-window transformation is used whose secondary window is split equally into two halves with a common center tap connection. Configuration results in each diode conducting in turns when its anode terminal is positive with respect to the transformation centered point C. Processed and output during both half cycle. Full rectifiers Advantages of full wave rectifiers are flexible compared to the half wave rectifiers. They are more flexible compared to the half wave rectifiers. Now you can see the clarity of this bridge rectifiers, which consist of 4 diodes, where you can you can see in this clearly. What are the advantages of this full wave rectifiers? Rectifiers takes place in both the cycles. It takes place in both the cycles of an AC input. The affluence of a full wave rectifiers is higher than that of a half wave rectifier. The rapid in the full wave rectifiers is lesser than the half wave rectifiers. And let's know about what are the disadvantages of this negative half cycle. It's more complicated than half wave rectifiers. It's more lightly complicated. It requires more diodes, 2 of the center tap rectifiers and 4 of the bridge rectifiers. PIV rates the diode is higher. Higher PIV diode are larger in size and too much costlier. The cost of the center tap transformer is higher. These are the disadvantages of the full wave rectifiers. These are the advantages of full wave rectifier. Thank you guys. Do like, follow, subscribe my channel. Thank you.